Determining domain and range of a function. Given a relation, defining y as a function of x, the domain is the set of x values in the function, and the range is the set of y values in the function. You've got to know that the domain is referring to the x values, and range is referring to the y values. Now they're asking us on these next four graphs to determine the domain and range. And this is a paper clip, green paper clip, and I use it to scan. You always scan from negative to positive. Now because I've got an x-axis and a y-axis, you've got to know where the negatives are and where the positives are. Now scan, you've seen a scanning machine. It comes in and it picks up information as it scans through. Now if you'll notice, I am scanning the x-axis. If I run into an arrow, that means negative infinity, because this arrow here means it's going on up but also out. So as you run into an arrow, negative infinity. As you exit the graph hitting an arrow, that means positive infinity. So the domain on this function, our first one here, would be negative infinity to positive infinity. Now I said a little bit earlier, you scan negatives to positive. So depending on what axis you're scanning, that's going to be dependent on whether you're doing domain or range. So as I come up from the negative on the y-axis, notice the first thing I hit is a y value of 2. It is being used, and then I scan on up and I hit arrows. So where the shading or the graph starts is at 2, the bracket indicates it is being used, and since I exited up hitting arrows, I've got positive infinity. So let's look at this next one. My domain, I'm coming in, I hit an arrow, that's negative infinity. Now where this one breaks off, it also picks up. So all the x values are being used, and I exit hitting an arrow. So my domain on this, again, is negative infinity to infinity. Let me scan my y's. As I come up this way, it looks like the first y value that I hit looks like a negative 10. And since it is being used, I'm going to use a bracket. Now you're looking at what values are used. So as I come up this way, if you'll notice over on this side, all my y values are used, and then it picks up again on the other side. So it doesn't matter if there is a break, but if all the y values are being used as you scan through, then that's part of the range. So I exit hitting an arrow, so that's positive infinity. And infinity always gets a parentheses. So let's look at the next one. Domain. As I come in, I hit an arrow. There is a hole, but a solid dot right above, so that's cool. But I end with a dot up here at a x value of 4. So I've got negative infinity to 4. I use a bracket. Now let's check on the range. As I come up, this is where it starts. I really don't run into an arrow because this is indicating that this is going straight on out. This is a constant value. So I am using a y value of 1. And then my y values pick up at 2 and go up to 8. Let's try this one. I hit an arrow, negative infinity. I hit another arrow, positive infinity. I'm scanning the x-axis, so actually this is all real numbers. Then scanning my y's, I come up, I hit an arrow. So I've got negative infinity, but if you'll notice, this curve stops right up here at, looks like a y value of 4. And I've got a bracket. So I've got a few more problems to look at, but we have to graph those. Some ask for domain and some ask for range. So let me get this back down here. So I'm going to have to get my calculator on. Let's go graph. Negative 3x to the third plus 2x minus 5. Let's go. Let me do a zoom 6. Okay. Now, someday, maybe the next TI that they make, they'll have little arrows here. But until then, if it goes off the your graph like this, you have to sort of understand there are arrows there. So as I scan the x-axis, I hit an arrow, I exit hitting an arrow. So that means my domain is negative infinity to infinity. My range, I hit an arrow, I exit hitting an arrow. So negative infinity to positive infinity. Let's look at the next one. See if I can move that so that weird light there. I'm going to turn this one off because I want to go down here and use this other one. And it's going to graph as red. Well, it just sort of starts right there. It looks at like the coordinate point negative 3, 0. So as I always do my domain first. As I come in, it looks like I have negative 3 and it goes to infinity. Range, it looks like 0 to infinity. Let me go to my table and let's see if there's actually a coordinate point at negative 3, 0. So it does not exist on the other side of negative 3 because we don't play with negative numbers. We play with real numbers when we graph. So let me go back to my picture. My domain, negative 3 to infinity. My range, 0 to infinity. Remember how you have to scan. For number 3, it looks like I have to do just domain. So let's do y equals, I'll clear this one off and this one. Maybe we'll go use magenta. So parentheses, negative 7 divide by x minus 8. Graph. Oh, that's cool. So let me change my window just a little bit. I'm going to do negative 5 to 15. I'm going to scoot it over so you can see that there's actually a physical break right here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Looks like an x value of 8. Let's go to my table. See, I've got y values, that's coordinate points, but I shouldn't have anything at 8. Notice it's an error. Because if I put 8 in this, I'm going to have division by 0. I can't have that. So, back to my graph, and I only need to do domain. So I've got negative infinity, it breaks at 8, picks back up after 8, and goes to infinity. So how I need to write this, notice I use a parentheses because I can't use 8. So I've got negative infinity to 8 union 8 to infinity. Domain on this one. Domain on this one. Actually, let me go. So I have got negative infinity to 8 and 8 to infinity. This is a union, so it means these are the x values I can use. So let me clear this one. So I've got 1 divided by square root x plus 9. So I'm going to have issues like with x at negative 10, negative 11, negative 9. If I have negative 9 here, I'll have division by 0, so I actually can't use negative 9. Let's see what our graph looks like. I'm going to have to change my window. So I'll do zoom 6. So if I scan, it is starting at negative 9, but I can't include. If you do second graph for your table, you'll find out you'll have an error message there. So my domain is negative 9 to infinity. 2 more. Well, let's look at this one now. Go to y equals clear. I've got 2 divided by 5, x minus 7. So I've got an imaginary arrow here pointing to my left and an imaginary arrow here pointing to my right. So as I scan through, I hit an arrow, negative infinity, exit, hit an arrow, positive infinity. My range, negative infinity to positive infinity. Alright. One more. Now before I graph it, you know this is a difference of perfect squares, and if I factored that, I'd have x plus 3, x minus 3. So something's going to happen at negative 3 and 3. I do believe we'll have division by 0, and I do believe we're going to have breaks on this one. So it's coming in, having a real good time. Oh, this is pretty. If you go to second graph for your table, you'll have error messages at negative 3 and 3. So as you scan, I hit an arrow, negative infinity, break at negative 3, break at 3, and I go to positive infinity. So my domain, got to indicate each one of these sections. I also have to indicate that I can't use some specific numbers. Going off my page. So that's it for domain and range. Remember to scan, and if you have to get a paper clip or use your pencil, it works as well. Thank you.